Hey everyone. So I'm Dean. I do protocol research at Status, and today I'm going to be talking a bit about VAC P2P, which is the messaging protocol we're currently working on over at Status. So first things first, what is VAC? VAC is a modular peer-to-peer messaging stack with a focus on secure messaging. So our goal really is to build a messaging stack where we kind of outline the layers of what goes into a messaging stack, like transport, data synchronization, etc., and outline sort of the APIs, the guarantees and requirements of each of these layers, but really allow for things to be changed for specific use cases. Because a messaging protocol doesn't only have to be used for like messaging if I'm talking to a friend, but like application layer messaging between like servers and stuff like that. And we want to kind of be able to execute on all of those use cases with a single protocol, and that's really what we're focusing on with this stuff. So when we're thinking about this messaging protocol, we kind of have to think about these layers so that we can design it correctly, and these are the ones we kind of have outlined right now. So the first layer you have is the application layer, which is the end user semantics, what the user really sees. So they know they're either in a one-to-one chat with someone else, they know they're in a group chat with someone else, they know that they're participating in a forum, something like Reddit, or they know that they're on Twitter, for example. Those are the application layers which we want to be able to facilitate. And those kind of inspire the entire rest of the protocol because we know what we want to achieve, and that kind of influences how the rest needs to be designed so we can achieve all those use cases. The next layer is data sync. This is the one we've started working on. This was the first one just because of the way things are working right now in Status. I'll get into that a bit later. That's really there for data consistency so that we can have unreliable transports but still ensure that people are getting the messages they're supposed to get. Yeah. Examples of something like that is MVDs, which is the protocol I designed, or BSP, which is the Briar synchronization protocol, which you find in the Briar app. Then the next layer is secure transport. This is confidentiality, PFS. Things like that are double ratchet, which you find in Signal, or MLS, which is messaging layer security. The next layer is transport privacy. So here we want transport and metadata protection so that people don't know who's talking to who, where the messages are coming from, things like that. For that you have things like Whisper, PSS, Tor, or Mixnets, things like Nimtech was working on yesterday. So now our design goals. How are we designing this entire protocol? So as previously stated, we're really looking for modularity and interoperability. So we want interfaces that allow for existing protocols to be used because we don't want to invent everything ourselves. We want to be able to build something where layers can interact with different protocols, but the protocol still works the way we designed it with the guarantees that we expected. And so we want to be able to facilitate existing and new protocols at each layer of the stack, and so that's one of the like driving design goals. So think of this kind of like libp2p where you can take different components together to build exactly the stack you require in the end. Better specifications. This is something which is kind of like very important, especially at Status right now. We see that our specs are not that great. We're like last minute going back and documenting all of the code to try and write specifications off of that, and that's not really perfect. What we want is we want more rigorous specifications. We want machine readable and formally verified specs, so stuff in TLA+, that also our guarantees are formally verified, that we know that our liveness checks actually work out and stuff like that. We want to be able to rigorously analyze all of our guarantees, all of the behaviors which our protocol is supposed to exhibit. Better simulations. So one thing which is also hard right now, for example, with Whisper is having these simulations so we know what the bottleneck is, how the entire protocol works. So what we're really trying to do is build out our protocol so we can do these simulations. We can go to other companies such as Whiteblock to help us test these things. And that's like one of the driving focuses we have right now as well. And it's been kind of tough because you have to design things in a completely different way, but it's working out. Another thing which is kind of important is mostly offline because we're really designing this thing for messaging between people mainly. And most people communicate on their phones, and phones are, most of the time, they're offline. So we need something which is reliable for mobile phones, that people get messages when they're online, but we don't want to have centralized servers which store those messages for them to be broadcasted to users when they become online. And we want to be able to enable excellent user experience. Right now, insecure methods are the better user experience, and that's why we all use them, right? None of us probably in this room want to use Signal group chats because they kind of suck. You can't remove people from a group once you've created it, and there's all these other issues with it. You don't always get notifications, stuff like that doesn't work correctly. I know myself, when I work on status, when I chat with someone on status, I barely get the notifications, and that's just not good enough. If something like Telegram or WhatsApp is providing this great user experience, why would I use any of this? Most users don't care. I don't even care, and I'm researching on this stuff. So data sync. This is the thing we kind of started out with, and that was because Status right now is working on Whisper. So we're using Whisper in our protocol. And Whisper kind of sucks because of the way messages are sent around. We expect that nodes are online, and for us to compensate for that, Whisper has mail servers, because messages expire on Whisper after a specific amount of time. So that means that if I'm talking to you and you're offline, you're never going to get that message. So what you end up doing is you end up going to a mail server and syncing it. And that's just like, why do we have this decentralized transport but then have a mail server to get my messages from? It kind of defeats the entire purpose. And so what we did is we designed a data sync protocol with that in mind so that we can phase out those mail servers and still get people their messages reliably without needing any of those. So that entire part of the architecture can now fall away, and we don't need those mail servers anymore for anyone to get their messages. So as said, one of the problems you see is that, like in P2P messaging, you come across this problem of reliably transmitting data. If there's no centralized server, you don't have these guarantees that a message will ever arrive. You don't have this availability. And one way of solving that, as said, is through a synchronization protocol. So the protocol I've been working on, it's called MVDs. It's minimally viable data sync. Minimally viable because it doesn't yet achieve everything which we need, but it achieves the things we need that we could get it into the V1 status application, and we already have more reliable message delivery than we did before. So how it works is kind of like TCP. So we have this TCP-like protocol on top of our unreliable transport to be able to compensate for Whisper. So what happens is there's two ways of transmitting data. We have an interactive mode and a batch mode. First, I'll quickly run you through interactive mode. What happens when I want to send a message to someone is I first offer that message. When someone receives that offer, they then request that message, and I will send that message to them. Now, in each stage, if I don't get the message in the next epoch when I expect it, I exponentially resend that message. So let's say I haven't received the message, or someone hasn't received the offer, they haven't responded to it, they haven't requested a message. I'll resend that offer. The first time I'll resend it after 3 seconds. Then I'll resend it after 6 seconds. And we'll always go up like that. And we do that at every stage just to ensure that messages arrive. So the thing which kind of sucks about this is that we have a far higher bandwidth, which is terrible for things like mobile, but it's the best we can deal with right now up until we add certain extensions to MVDs. And we do that. So people request the message, then we send the payload with the actual message, and then once a user has received that message, we send back acknowledgements to ensure that the peer stops sending that message. That's the interactive mode. So this one has a lot more steps. It means that we don't need to send the entire message payload all the time. We have a smaller payload, which is the offer payload, which just contains a message ID. And then we have the batch mode. Batch mode is nice because we don't have to do the offers and requests. We just keep spamming out these messages, and we keep sending the messages exponentially as we did before up until someone acts the specific message. So this one works a lot easier, but it is better for higher bandwidth devices. One of the nice things about MVDs as well, or about these data sync protocols, is that I don't need to know for example, if I'm in a group chat, theoretically, for the topology of how we're communicating is I don't need to know every person in the group chat. Because, for example, I'll share the message with, I'm A mobile, I'll share the message with B mobile. B mobile knows that desktop D is part of this group chat, but A is not directly connected to desktop D. So B will automatically transmit the messages that it has received to this desktop. That adds certain issues with handling group chats, like how do we ensure that users who are no longer supposed to be in a group chat are still part of the group chat? How do we ensure that everyone who is receiving or is supposed to receive messages actually receives that message? And those are still open research problems which we're working on to try and solve those and figure out what the best topology is for how to peer people within various chat types. And then to inspire us or to guide us through what we have to do after that is we have these problems and rough priorities which kind of outline how we're going to go ahead and do the rest of our research. Because data sync asset came in so that we could make Whisper more reliable in the meantime, but it also allows us to easily, in the future, switch away the Whisper transport once we have something that's more reliable. So one thing we want is we want better data sync. What we don't have right now is we don't have a remote log. So what would be great is if we could use something like IPFS or PSS by Swarm or just Swarm storage to store these messages that my peer doesn't need to be online so I receive the message. So they send me an offer, I know there's that offer, and I can get that message from a reliable storage without having to wait for my peer to be online again. That's something that Oscar is working on right now. We want better scalability for multi-user chat contexts. Just imagine this interactive mode in a group chat with 100 people where everyone is spamming messages. Like, we're in blockchain week, you probably all know it. You're in some blockchain chat. Just imagine for every message you send to every peer, it sends out 3 messages. That's a lot of bandwidth, and we don't want that. That's a terrible experience. It's going to run through an insane amount of data, and it just doesn't work. Better transport. As said, Whisper is not scalable. It's not spam resistant, and it's not incentivized. Whisper's current thing for spam resistance is proof of work. That's fine. It's not good for mobile. Just imagine you have to do proof of work every time to send a specific message. That might work if we lower the proof of work, but that means that I can spin up an AWS server and just start sending everyone messages like crazy because the proof of work is so low that it doesn't really matter. Incentivize is also a problem. No one's really running Whisper nodes because why would I? There's no point. There's not that many services using Whisper right now, and I'm not being paid for hosting a Whisper node, so I'm just never going to do it. And also, the way Whisper works right now is kind of weird because you just kind of send messages to, or you, as a user, receive all messages, and you kind of have to filter through which ones you want and which ones you can actually read. And that's just not good enough. Adaptive nodes is something that we're working on closely with the people over at Swarm, because light clients are mainly leeches right now when they really don't want to be. Light clients are kind of designed in this way where they get a lot of things for free, but they don't do anything in return. For example, if I have high data on my phone, I have unlimited data, I can broadcast messages to other people, and it makes no difference to me because I have unlimited data. Light clients right now don't do that. With adaptive nodes, what we do is we take the way a normal node works, we filter out specific things. So like we say, if I get more storage, I'm going to start storing messages for other people. If I get more bandwidth, I'm going to start broadcasting messages for people, just so I can actually be a useful part of the network and contribute to the entire thing. A shout out to the guys over at Web3, Validity Labs, and NIM. They've really been helping on this entire messaging research. They're the ones mainly working on Mixnet, which has been super useful, especially the NIM guys with the presentation you saw from Harry yesterday. That's been helping us out a lot, and we really are excited to continue collaboration with a bunch of these teams, because it's not just status that needs this. Everything needs reliable messaging. If we want to actually build this decentralized stuff, we need the things I've been talking about now. And so yeah, to anyone who wants to contribute, just reach out to us, and we're always happy to have more people help us out and figure out ways to collaborate with other people. For like quick summaries of what we're doing, for longer blog posts, you can go on vac.dev. If you guys are interested in some of our specs, go on specs.vac.dev. Most of them are written very concisely. We're going to, as said, start formally verifying a lot of them, having proofs for all the guarantees we want to achieve. On Twitter, we're vacp2p, and I'm Dean Eigenmann. If you guys want to like reach out, want to learn some more, my Twitter is open, my DMs are open, so you can just message me. Are there any questions? Thank you. Anyone have any questions? Ultralight Beam is not a messaging protocol. Huh? He asked if I'm working on a peer-to-peer messaging protocol called Ultralight Beam. Ultralight Beam is not a messaging protocol. It's a mannet protocol. So how to send messages in offline environments over like Bluetooth or Wi-Fi direct. And we're still working on that. That's probably going to be more part of vac.dev with all the other people who are working on it, like ChainSafe. Yeah. Anything else? Okay, thank you.